Welcome back to the channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. And if you'd like to make a tax-deductible donation to our program, please go to smarturl.it/help-ISU-actuary. Here's a problem for exam P on probability for November 9th, 2017. The number of policies that an agent sells has a Poisson distribution with modes at 2 and 3. K is the smallest number such that the probability of selling more than K policies is less than 25%. Calculate K. So what you need to know for this problem, the most important message of this problem, is that you need to memorize the mode of the Poisson random variable. And the parameter of the Poisson random variable, typically denoted by lambda, if for a Poisson random variable, if that parameter lambda is considered, and it's the mean of that distribution, then the mode is at 2 points, if lambda is an integer, lambda minus 1 and lambda. And if the mean is not an integer, then the mode is the greatest integer function applied to lambda, so the greatest integer part of lambda. That means basically the integer just next to the left of lambda, because lambda is on a positive number. In this case, we are told that the mode is at 2 and 3. That means that lambda minus 1 is 2 and lambda is 3. Because for an integer value of lambda, the mode is at lambda minus 1 and lambda. So let us write n for the random number of policies sold in this problem. We're looking for the first integer k such that the probability that n is more than k is less than 0.25, and that's equivalent to finding a first integer k such that probability that n is less than or equal to k is greater than or equal to 0.75. Now k is just a number here, it's not a random variable. N is a random variable. Well, in order to find that integer k that we're looking for, we just evaluate the probability that n is less than or equal to 0, n is less than or equal to 1, n is less than or equal to 2, n is less than or equal to 3, so on, until we get to the point where that probability exceeds 0.75. And probability that n is less than or equal to 0 is just probability that n is 0, which is e to the minus lambda. In this case, lambda is 3, remember, so it's e to the negative 3. And that's about 0.05, it's definitely less than 0.75. For n less than or equal to 1, it's the previously calculated probability that n is less than or equal to 0 plus probability that n is 1. We can actually combine the terms that have e to the negative 3 in them, so that altogether ends up being 4 times e to the negative 3. Because remember, the probability that a Poisson random variable is equal to a specific number, little n, is e to the minus lambda times lambda to the n of an n factorial. Again, you have to remember that for the test. There's absolutely no question about it. So in this case, it's e to the negative 3, about 4 times the first value that we calculated. It's about 0.2. It's definitely less than 0.75. Well, then the next value is the probability that n is less than or equal to 2, which is the previously calculated, and probability that n is less than or equal to 1, which was 4 e to the negative 3, plus probability that n is 2, which is e to the negative 3 times 3 squared over 2 factorial. 3 squared is 9, divided by 2 is 4.5, so 4 plus 4.5 is 8.5. So this is 8.5 times e to the negative 3, or 8.5, roughly 8.5 times 0.05, which we approximately calculated as e to the negative 3 in the first part. And that's still less than 0.75. It's about 0.423. For probability that n is less than less than or equal to 3, it's calculated previously probability at n is less than or equal to 2 plus probability at n is 3, which is e to the negative 3 times 3 cubed divided by 3 factorial. And altogether with 8.5 e to the negative 3, this is 13 times e to the negative 3, or roughly 13 times a 0.05 that we calculated in the first part. So it is it's just under 0.65. That's less than 0.75. And finally, for n for calculation of probability n is less than or equal to 4, that's the previously calculated probability of n less than or equal to 3 plus probability that n is 4, which is e to the negative 3 times 3 to the 4th over 4 factorial. With 13 e to the negative 3, which was the probability that n is less than or equal to 3, altogether this ends up being 16.375 times e to the negative 3. And just 16 times 0.05 is already 0.8. Is that right? Because 10 times 0.05 is 0.5, and 6 times 0.05 is 0.30. So this is definitely more than 0.75. And therefore k is 4. And that's answer D. In fact, it's nice to do all the calculations here, but you can do a rough estimation once you see that the probability at n is 0 is approximately 0.05. You could estimate the other values, and you will see now you are less than 0.75 up to 3, and then you go over because it's more than 16 times 0.05. Let's answer D, and that's the solution of this problem. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries and belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.